to support us.
Signaling, slowly.
That's very good. We love you, sir. আমরা দেখি 2-1 মিনিট আর সুদীপ কোনো খবর আছে আমাদের চেয়ারম্যান সাহেব জয়েন করছেন কিনা?
উনি কিন্তু আছেন এখন, কালকে চলে যাবেন বলছেন।
ও তাহলে আমি
একটা ফোন করে দেখুন।
সুদীপকে সঙ্গে কথা হচ্ছে কিনা আমি জানি না, সুদীপকে জিজ্ঞেস করছি, ব্যস্ত ফোনে করছে। সুদীপ, আমাদের সন্দীপ জয়েন করার কোনো ইয়ে আছে, জানা খবর আছে তোমার কাছে?
না, আমার কাছে নেই স্যার।
আচ্ছা, আমি একবার দেখছি আমাদের চেয়ারম্যানকে ফোন করে দেখি।
উনি ধরছেন না, চেয়ারম্যান সাহেব কি ধরছেন না?
না, উনি তো ব্যস্ত আছেন কোনো কাজে আমার মনে হচ্ছে, বা ক্লাস নিচ্ছে, আমি ঠিক জানি না। তাহলে স্যার 1 মিনিটের মধ্যে আমরা শুরু করি, 6:05, 1 মিনিটে শুরু করবো আমরা, কেন আমরা দেখতে পাচ্ছি অলরেডি 27 অ্যাটেন্ডেন্স আর অলরেডি দেয়ার, টু রেসপেক্ট দেয়ার টাইম, সো শুড স্টার্ট। অল টুগেদার উই আর 33। আমরা এইখানে স্ক্রিনে 6 জন আছি, বাকি তো কেউ নেই দেখছি। তো আমাদের সুদীপ, তুমি কি একটা চ্যাট বক্সে চ্যাটটা দেখছো? একবার দেখো, মিস্টার দেবাশিস রায়চৌধুরী একটা,
হ্যাঁ আমি ওটাই দেখছি, আমি লিংকটা দেখছি।
তুমি দেখো, তুমি এটা তুমি ছাড়া তো কেউ করতে পারবে না।
না, আমি লিংকটা চেক করছি।
ওকে দেন, ওকে ওকে। প্রফেসর ব্রহ্ম, উইথ ইওর কাইন্ড পারমিশন আমরা ঠিক আছে। গুড ইভিনিং all the participants, panelists, and our Assistant Technical Director, Institute of Engineers, Sudeep Chakraborty, and my joint convener, Chanchal Chakraborty. সবাইকে শুভ বিজয়া and Dasera to everybody. Dasera of course চলে গেছে. Now we'll start our session. This evening we will be discussing on cloud computing and telecom business support system. We have two experts from the industry, Mr. Shoibal Ghosh, lead and principal solution architect from Ericsson India Limited, and his colleague, Mr. Indrajit Nandi, he is IT architect with Ericsson India Limited. So with this, I would invite Chanchal Chakraborty, joint convener, Electronics and Telecom Engineering Division, West Bengal State Center, to introduce our panelist. Chanchal, over to you.
Thanks, Ramda. Good evening, everyone. Today we are having webinar on cloud computing and telecom business support system. This time we are having author on cloud computing by Mr. Shoibal Ghosh. He is having the best-selling book on cloud computing, and Mr. Shoibal Ghosh is currently employed as security lead cum principal architect in Ericsson India Limited. He has an overall experience of more than 23 years in different areas of technology, including cloud security, Docker, Kubernetes, databases, and operating system. He has numerous industry and vendor neutral certifications around cloud security, database, and cyber security. He is very deeply involved in architecting secure and workable solutions for global customers and spends a lot of his time working on these nuances of architecture and security of the different telecom systems being deployed at the customer locations. He is well experienced in areas like security, solutioning, system integration, and consulting. He is obsessed about the technology and technical communication and works
Please louder.
The technical communication with various stakeholders are precise, correct, and meaningful. His colleague, Indrajit Nandi, is an IT architect with over 17 years of experience in the mobile telecommunication industry. He is a TOGAF certified platform architect with documented success in creating IT infrastructure in the private and public cloud environment. He is experienced in areas like system integration, solution architecting, consulting in large-scale transformation, integration, and implementation engagements with leading global organizations. He has expertise in IT infrastructure, BSS implementation, BSS continuity support, and vendor management, etc. Now I welcome the speakers today to start their topics. See Shoibal Ghosh. At the very outset, he will take up the topic on cloud computing and followed by presentation on telecom business support by Indrajit Nandi. Mr. Shoibal Ghosh and Indrajit Nandi, it's all yours. Platform is yours. Please take up the sessions. Thank you very much.
Thank you, sir. It's an honor to be here present today to take a session on cloud computing and BSS. So let me first share my screen and start the session. Give me a minute. Start.
Shoibal, is it possible to see you on the screen?
Yes, I will start. Yes,
yeah,
I'll
please.
Start my video camera also. Am I visible? I think
yes.
so.
Perfectly. And your screen is also visible.
Okay, fine.
Fantastic.
Okay, so to start with, we will be talking about cloud computing and telecom business support systems. So I will be talking more about cloud computing today. I will be discussing the basics of cloud computing. We will try to understand the terms and terminologies that have come across with cloud computing, because cloud means a lot of things to a lot of people. The interpretations are not uniform. So we will try to see how we can interpret cloud in a uniform way. What are the challenges with cloud? What are the benefits with cloud? And how it becomes meaningful for the telecom operators. It's meaningful for a whole lot of other people as well. A lot of industry people will be using cloud. In fact, in the next 5 to 10 years, I believe a lot of our industry will move to the cloud. So let's start. So what we will be discussing today is what exactly is the cloud, which means that we will be looking at one or two definitions of the cloud. Basically, there will be no cloud if there is no virtualization, which means that virtualization acts as the backbone for the cloud. So this is something we will be discussing. When we talk about cloud and virtualization, microservice-based applications is also a part of the whole setup. In fact, it is no ideal coincidence that containers, microservices, and cloud became terms which are being used and which are the technologies in vogue today. Then we talk about service models and deployment models on the cloud, because this is where the actual meat of the whole thing is, which means that we need to know how the cloud is deployed, how we are actually using the cloud. And then we touch briefly on the security considerations for the cloud, because I believe that when we have cloud, a lot of things come into the picture which were not there before. For example, you start having a third party in the equation which was not there before. Before you had only the telecom operator and the customer. Now you have the third party, the cloud vendor. So there is a lot to do with security, but we touch on it. And also there are lots of governance that we need to talk about. But anyway, let's get started and let's go on defining the cloud. So there are a whole lot of definitions of the cloud. Different bodies like NIST and other bodies have defined cloud in their own way. But for me, cloud is just a simple a pool of resources where we actually have this stacked somewhere, and from where we actually let it out to the people. So if I take an example, say a consumer needs certain number of CPUs, certain amount of memory, certain amount of storage. The cloud is there for that person to actually ask for it and take it. All they need is a network. So when the client is done, they can release the resource. So if I look at it from another angle, all I'm doing is I don't need anything. I don't need a server. I don't need the storage. I don't need network. In fact, I don't need a data center. I just need a network, a broadband connection, and I can actually get the entire stuff for my use. So it's very straightforward. Okay. Now, if you look at why we need the cloud, I mean, that's fine. We were able to define the cloud. But what is the inherent benefit it provides? The first and foremost benefit is resource pool. So think of a situation where you need some additional resources suddenly. Why will you buy another server, or how will you provision another server at short notice if you do not have the cloud? Think of telecom operators provisioning the servers. They have to provide for the peak capacity. So maybe in a year during, say, Christmas time or even Dashera or Diwali, there are lots of traffic going on through the network. And probably at that time, because of the traffic, they will need to provision extra servers, more network capacity and other things. So they will have to provision that whole thing, but the servers will remain idle for the rest of the time. So this is a wastage. Now, one of the ways we actually take care of that is through resource pooling. You just, whenever you need an additional server or additional network, you just take it from the resource pool. Basically, you need a broad network access, which means all resources are available over the network without any need for physical access. I mean, network is not part of the service. All you need is that you should have the network available. Rapid elasticity is a very inherent part of the cloud, which means that once you have used the resources, you automatically can release the resources without any third-party intervention. The whole thing happens seamlessly. And the final part of it is that whatever service you use, you can actually measure it. In other words, just like any other utility like water or electricity or anything, you only pay for what you use. So this is interesting because in the future, I see that you will probably move from a capex model. That is, you won't be investing in capital expenditure, but you actually will move to an operational expenditure, which is an OPEX model. Okay. Now, we were talking about models on the cloud, because when we talk about cloud, we are forever talking in certain terminologies like IaaS, infrastructure as a service, platform as a service, software as a service. I would like to clarify this briefly. So, what is infrastructure as a service? So infrastructure as a service is a type of cloud computing service that offers essential compute, storage, and networking resources on demand on a pay-as-you-go basis. So if I were to simplify this further, my storage, network, and compute is my infrastructure as a service. So let's put it this way. I have the basics of installing my operating system. So if I need to install an operating system and I don't have anything else with me, I can just use the infrastructure as a service cloud, infrastructure as a service from the cloud, and install an operating system and do my work. The platform as a service goes one layer higher. It provides you a computing platform, which typically includes an operating system, program language execution environment, databases, web servers, middleware, etc. So in other words, what I mean here is that frequently I don't have the resources or the means to install a database or the middleware. So what I do is I go to the cloud vendor and just take the platform as a service. So it comes with its own operating system, with a choice of databases. We also have choice of languages. So here the focus is that we are trying to build an application, and we don't want to be bothered with all of the stuff that is underneath. Software as a service goes even one level higher, which means, like, let's say an example. I want to use Office 365. I don't want to pay the license cost, and I don't want to be bothered with anything else. So I just use that software. And the software, I just gave Office 365 as an example of an application. It can be very complex applications. And as Indrajit will later show you, there will be telecom applications which are running on the cloud. Okay. So these are the three service models. And typically, whatever you do, wherever you go, these three models will always be there. These are not going to change. Now, at the very outset, I have spoken about virtualization being the backbone of the cloud. So if there was no virtualization, there would not have been any cloud. Simply, if you look at the traditional architecture diagram, you will see the application, below it the operating system, and then the hardware stack. But if you see the virtual architecture, you will see the hardware stack. Then there's a virtualization layer, there's hypervisor layer, and then you have the guest operating systems and the applications sitting on top of it. So what this essentially means, and I think which is very significant for you to understand, is that on the same hardware, we can install different operating systems. So I might have different flavors of Linux, I might have Windows, I might have any other operating system, as long as we have the hypervisor layer correctly installed. And maybe we want to use, let's say, a database like Oracle on Windows, and also we want to use Oracle on Linux. So because we are able to do this, the entire concept of cloud came, because cloud is nothing but a huge infrastructure where you have the virtualized layer, and on top of the virtualization layer, you have different operating systems and applications which are being sliced and given to consumers. Okay. So a very key component of the cloud is virtualization. Now, if you have any questions, I don't know how we are going to ask the questions. Maybe you can directly stop me and ask questions, because I don't want to go on if there is something in your doubt in your mind, or you might put it on the chat, which I will take up at the end of the session. Okay. So when we talk about cloud, a couple of other terms came along in the last few years. One is microservice-based application. Because we are talking about cloud today, now let's understand what a microservice-based application is. Think of a situation earlier where you had an application and the customer wanted a minor change into that application. So to do that change, the whole thing had to be brought down. The change has to be done, and then it has to be tested, and everything has to be reinstalled and everything rerun. So it was a huge job doing even a minor change to an application. But now what has happened is our applications are being developed as microservice based. In other words, it's like small components are being put together. Each component can run on its own. And if you need to change any component, you simply sort of unplug that component from the monolithic code base, make changes to it, and plug it back. Now, this is very important because microservice-based applications, typical use case is being used on cloud with containers, because there's another term that I'm going to explain in a moment, which is containerization. So just to repeat myself, a microservice-based application would typically be an application that can be changed, or simply the application can have numerous components that can be removed from the main body of the application, changes made to it, and the whole thing plugged back, so that without taking down the main application. So this is very important because there's no dependency on other part of the application, and that it can so be that one part of the application use as a language like Python, while the other part of the application can use a scripting language like JavaScript. So this is something that has come along with the cloud. Now, there's another point here. We are also moving towards containers. Now, what exactly is a container? Because this is a term I'm sure you have heard a lot of times, or you're definitely going to hear it in the realm of cloud computing. Now, containers is basically, the whole application with its runtime and all the execution environment that needs for it to run is available to be run at any place. So let me give you a very practical example, the kind of things that we see in the industry or saw in the industry a lot. In fact, we see it even now. What happens is probably an application is developed in a test environment. It runs fine. It is as per the customer specifications. Everything is tested. But when we try to run it on the customer environment, it doesn't run, or it runs very slowly, or there is latency problems, or there is some other problem. What happened? It's probably simply at the customer environment, probably the system that was running didn't have a certain library, or something was different from the test system, and that is what caused all the grief. But with containers, what happened is not only are you having the application, but along with the application, you're also having the runtime execution environment with it, which means that I don't care where I'm running the application, because it's based inside a container, and it goes, not only the application goes wherever it has to go, but also the execution environment goes with it. So when we talk about cloud computing, we also have to be cognizant about microservice-based applications as well as containers. So please ensure that you understand these three terms. What is cloud computing, what is containers, and what is microservice-based applications. Let's move ahead. So some confusion may be there between what is containers and what is virtualization. So if you look at this diagram, and if you look at the left side, you will see that it shows the virtualization concept, which is like an application is running, the binaries are there, and the guest operating system. So it's very important to understand that the guest operating system is a key component of virtualization. Every application will have its own guest operating system. Then the hypervisor layer, the piece of software that makes virtualization work the way it does, and then the host operating system. Okay, so what is container and how it is different? In containers, you have a container engine. And one important thing to note is that there's no guest operating system. So we can run numerous containers using or leveraging the host operating system. So just to put things in perspective, we might have a microservice-based application running certain components in a container which is on the cloud. So this is how we envisage applications running in the future. So it's a bit complex, but this is something that people start understanding when they understand the concept of modularity. So the applications is module-based. Each application can be run on its own. The applications are put in containers, so that makes it runnable from anywhere, and then we put it on the cloud. So let's move ahead. So if we take a step back and do a schematic representation of the service models in the cloud, if you pay attention, you will see the infrastructure as a cloud has the facilities, the hardware, the abstraction, the core connectivity and delivery, and the APIs. In other words, for me, it's network plus compute plus storage. So this is my IaaS. On top of it, when you put the integration and middleware layer, you get the PaaS. Again, for me, it means the databases and the platform for development of applications. And the final layer, which is software as a service, you have the presentation modality, the presentation platform, the APIs, the applications, the data, and the metadata and content. So for me, it's the user interface, the applications, and all of the associated metadata with it. So this schematic representation kind of gives us a good handle on what cloud means, how it works, and what are the service modes. Okay. Okay, let's move to the next. So I'm just checking the chat, whether there are any questions on the chat or not. Okay, there's a question whether an universal rate tariff fixed for availing resources in the cloud. Yes, there is a rate, a tariff is fixed for availing resources in the cloud because it's metered. One of the points that I mentioned earlier in the when I was defining the cloud was that it has to be measured. There has to be a way of metering it, and based on that, there is a tariff for it, and it's fixed on the way on your usage. So whatever you use, whatever you consume, you pay for it. Nothing more, nothing less. Okay, let's move to the next screen. Okay, we are moving to the deployment models in the cloud. So you have heard of public cloud, which means a cloud which is available generally to the public. In other words, let's talk about Amazon Web Services, AWS. This is a public cloud. Anybody can take a piece of the cloud, if I may put it in this way. They can rent the cloud and start using it. There are lots of other public clouds. For example, when I was writing the book on Docker, I used DigitalOcean Cloud a lot to run my tests. There is Google Cloud, there is Oracle Cloud, there is Azure from Microsoft. So a lot of public clouds are there, and they come with a tremendous amount of or let me put it, number of features, and sophistication level of those features are enormous, which means that I can have, for example, AI ML embedded into the cloud. They can do stuff like analysis of unstructured data. We can have public clouds which give us, for example, simply a database as a service, or we can even have security as a service. So a public cloud is there not only to give you infrastructure as a service, but most of the usage these days are using the software as a service. I see a lot of usage of the software as a service component. AWS was more biased towards the infrastructure as a service. Now, there is a private cloud as well. Typically, the private cloud is used by a single organization or a single set of organizations. It may be managed by the organization itself or a third party, and we maybe look at it on premises or off premises. For example, I can give you an example like Oracle has a private cloud, which it's an appliance called Exadata Cloud Service, which it goes on, puts in the premises of the customer. It's a private cloud. Oracle manages that cloud. The customer uses the cloud and pays a rent on it. So that's an example of a private cloud. A community cloud is shared by several organizations who have a common purpose. For example, they have maybe enhanced security requirements, or maybe they have the same kind of mission or policy or governance and compliance considerations. So they are part of a community cloud. So again, it can be managed from anywhere by a third party and maybe look at it on premises or off premises. The hybrid cloud infrastructure is a composition of two or more clouds. So typically, use case would be, let us say I have a lot of things which I keep in my organization, but my backups or my archives, not my backups, my archives, I put on the public cloud. Because while I need those archives from time to time, I don't want to invest in servers and other paraphernalia for keeping it on premise. So hybrid cloud would be using, say, your own data center plus the public cloud, or it could be a combination of private cloud plus public cloud, or it could be a combination of a community cloud and public cloud, and so on and so forth. But the important thing is there is a very strong connection between the two clouds, which means even if you are using a public cloud, there is a strong connection, maybe because part of the data will be on the other cloud. So typically, we will not consider a hybrid cloud as a hybrid cloud if we have two separate stacks of cloud. Okay, so I don't see any more questions. So, or I do see questions, so maybe I want to answer some questions. So I don't see any open questions. Okay, do ask me if you see those, if there's any other question, please feel free to ask. So let's move to the next slide. So now we want to put it all together. We have been talking a lot, so there's something we now want to take a concrete step, which is like how it's all structured together. So the characteristics of a cloud is resource pool. So we pool all the resources. There is a broad network access that is expected. There's a rapid elasticity, which means we can grow and contract. There is a measured service, because if you don't measure, you cannot fix a tariff for it. And it's on-demand self-service, which in other words simply means that you get it with minimal intervention or absolutely no intervention. So it's seamlessly done. This is the characteristic. The service models are SaaS, PaaS, and IaaS. We have already discussed that. And the deployment models are public, private, hybrid, and community cloud. Okay. So moving to the next slide. So till now, it was all good news about the cloud. So are there any downsides? Are there any upsides? So because I'm running out of time, so I'll just quickly go through this. First thing is you move from the CapEx model to the OpEx model. So you don't make a capital investment on servers, on your data center, on an entire staff for maintaining the whole thing. You move into an OpEx model, which is nothing but where you are actually paying a rent. So that's point one. And everything, the administration part is completely outsourced. And because it's also outsourced, and there is there's an interest for the cloud vendor to see that it offers an optimized performant cloud. So the whole system is optimized for performance and high availability. So what are the downsides? The first downside is you don't know where data is stored. You're not aware where data is stored. It can be stored here, or the server may be in some other country. So that's a challenge. There are security challenges on the cloud. Big security challenges come in, which I'll discuss quickly in the next slide. Vendor lockout and vendor lock-in. So what is vendor lock-in? Vendor lock-in is, I like to put it this way, there would be proprietary applications or proprietary controls and proprietary data which will not allow you to move from that CSP or cloud service provider to another cloud service provider. For example, if I am using, let's say, AWS, and there's so much of proprietary stuff there, I cannot easily migrate to, let's say, Microsoft, then that's called vendor lock-in. Vendor lockout is when, let's say, for some reason, at some stage, the vendor doesn't offer a service. It was previously offering, let's say, database as a service, and suddenly it stops offering that service. And you're stuck. You don't know how you will move the stuff, or the data is locked. So this is a real big issue. Security in the cloud, there is a lot of security there. In fact, we can do a complete session on security in the cloud. There are security issues faced by the cloud providers, faced by the customers. For example, if my data is on the cloud in AWS and it gets hacked, who is responsible for it? If the data is stolen by another party who is also using the same cloud, who is responsible? What is the relation between the cloud service provider and the tenants from a security perspective? So basically, the whole idea here is that we have a completely new domain of knowledge that needs to be thoroughly understood, which is security in the cloud. Because as I said earlier, previously it was between the telecom operator and the customer. Now a third party comes into the equation with a very complex structure known as the cloud. So there are lots of security risks. I mean, I just spoke about hacking, but there can be lots of things that can happen. Which is, for example, a typical security threat could be that the cloud service provider themselves might start using the data that you have provided. For example, let's say, since they are able to see the data, they use the data, or the, let's say, the phone numbers, and they have a repository of phone numbers that they can use. Even with good intentions, they can use it, or even malicious. It doesn't matter. But it's just that your the private information has gone to another party. So lots of security threats. And then we come to the final part of our day. There is a lot of governance that also comes into the picture, because if you talk about security, and there are lots of frameworks and other things that are there, since there is a contractual agreement between the cloud service provider and the telecom operator. So there has to be a lot of governance that needs to be there. Otherwise, there is no guarantees. I mean, neither the customer nor the telecom operator will be comfortable with using a cloud if it was not governed with any way. So there are lots of governance models. So since in the interest of time, I will not go deep into this. But again, as the governance part of it and the security part of it is indigenous to the whole cloud ecosystem, and we need to pay a lot of attention to this part. Okay, so what are the popular public clouds? Amazon Web Service I mentioned, and for me, AWS is perhaps the biggest player in the market, more than 50% of the share. Azure is very good with lots of applications and technologies. Google Cloud is coming up very fast. Oracle has a different type of cloud offering, but it does have very, very strong basics. IBM Cloud is also there. So these are some of the popular ones. There are lots of smaller players also, but I would say that the ones you see on the screen are the main players. And I think we can now sum up. This is my last slide. So we are now aware of the definition of the cloud. Hopefully you have understood something. We're aware of virtualization as the backbone of the cloud. We did talk about it. We had a quick glimpse of microservices and containers. We looked into the service models of a cloud. We looked into the deployment models of the cloud, which is like private cloud, public cloud, community cloud, and hybrid cloud. And we talked a bit about security and governance in the cloud, as well as named some of the top players in the public cloud tools. So that more or less concludes this. And I'm not sure if there are questions because I didn't see many in the chat. So quickly open.
Mr. Ghosh, we will have a question and session at the end of Indrajit's presentation.
Okay,
If you don't
sure.
mind, if you kindly, because we'll
Yeah.
answer together. Okay. Thank you so much for your beautiful presentation. I will invite now Mr. Indrajit Nandi to take over.
Thank you.
Thank you.
Good evening, everybody. Just let me quickly blow up my presentation. Hope it is visible to all. The presentation is visible, correct?
Yes, absolutely. We like to make you visible also.
Okay, I'm trying to just
Okay. Thank you so much.
let me. I hope it is visible, correct?
Great. We can see you now.
So all set.
Very good. Excellent. Now,
So thanks, Soibalda, for helping us to understand what the cloud is. Now we're trying to see how the cloud is.
Your voice is not audible. Be louder.
Is it good now?
Yeah, absolutely fine.
Absolutely. Good. So thanks, Saibal, for helping us to understand what cloud is. Now we will try to understand how this is impacting or changing our world. Okay. So we will see that how some general concepts of BSS, and then we'll see BSS data flow architecture, then BSS evolution with virtualization, the benefits of cloud platform in the telecom world, BSS architecture, how it's shaping in the cloud platform, and how what are the different cloud services are offered to set up the new telecom BSS platform in the cloud. So let's start with the very basics. How our users see a telecom world. For most of us, we use our telephone or mobile phone nowadays. We make calls and towards some other our friends and family, and or maybe we look for services like the cab services or like food ordering services like Zomato. So for us, when till we are connecting to any other mobile or any other service provider, we are fine. We as a user, we don't bother about who are involved to make it happening. What are the different complexities behind that? So that's a less bother to user. But towards the CSPs who are behind this connecting calls, they are not happy with this only because they want to monetize their platform. So the CSP is giving us a platform using which we connect other mobiles or any other service providers. But what in turn the CSP also needs to monetize its a platform services. So what it involves, they so for us, we use three services. Either we do a voice call, or we do text, or we look for internet services. So these are the three basic services are being offered by any CSP. Now CSPs are needs to monetize their platform against these services. That involves sales and marketing, product offering, customer support, resource allocations, service activations, billing or revenue generations, and then assurance. So all these components together are forming a BSS and OSS platform for any telecom operator. So BSS is basically the customer focused business process for any telcos, which helps them to monetize their platform. Okay, and OSS is the fulfillment and assurance of this same platform, so that once a customer is acquisition is completed, he's part of the CSP and he's using CSP network. So OSS business process helps to monitor that whether customer is ensured that services and customer continues to enjoy that services as long as he's paying for that. Now this evening discussions will be primarily focused on this BSS business process and how it is changing with the evolution of cloud platform. So let us first understand what are the different BSS component roles. Okay, so there are four basic pillars of BSS. One is product management, then customer management, revenue management, and order management. Product management involves like product development, sales and management of product, offers, bundles, and business and mix market customers. So products for a CSP is basically, you go for a mobile connections, you go for a postpaid or you go for a prepaid connections, and then prepaid has different tariff plans, maybe postpaid has different tariff plans. These are part of this product management. Then customer management. Customer management is basically the channel using which customer interacts with the CSP. Okay, it may be for a service request, it may be for a change service request, or it can be a complaint also. Okay, or it can be also a partner management. There's not only customer to business, it can be a business to business, B2B kind of also. There are services offered from a CSP. Okay, so for that it's a partner management, also part of our customer management. Then it's come revenue management. Revenue management involves the billing, charging, and settlement, which is basically the monetizing part of the customer of the CSP's platform. Order management, any service provision in the CSP platform, which involves a order. Okay, so be it a customer acquisition or customer provisioning in the platform, or be it a changing of any plan services, adding, modifying any services, or maybe termination of services, everything, what are the changes happen to a customer life cycles in his service. So it all involves with some order. Okay, so these orders are basically a workflow which executed in different CSP nodes to either create a service or a modify a service for a customer. So these are the four pillars of a business support system, which helps a CSP to monetize its platforms against the service it provides towards its customer. Now, this picture typically looks, represents a typical stack of a complete BSS components in general. So this involves three tiers. The first tier is, you see, this is the customer or user management layer. Okay, if you see, this layer is responsible to interact the CSP with its customer. A customer can call a call center. A customer can use a web self-service through web server. It can do a USSD to make any request. It can have a different other partner channels. So these are the first layer. What we see here, it's all user management or customer interaction channel. Today we call is omni channel. Earlier it was, if you go back a few years, then it was only either you have to call a call center, or you have to go to a POS, a retail shop, for any service change or new service acquisitions. But now you have sales services, you have USSD, you have also mobile app based. The CSP is also giving you an app also to make you the changes into your service. So now it is called a omni-channel customer interfaces through which customer can interact with its CSP for any service request or service modifications. And then the second layer is the SOA, or it is called a enterprise integration layer. So otherwise, if you see, if this layer doesn't exist, then every single services has to be integrated with each other as a mesh architecture. Okay, so then it will be very difficult to manage those integrations, and to, if there is any change happen to this integration, to incorporate those changes, it will be very difficult, and that may include large maintenance window. The changes will not be that fast, it will not be agile. So this layer has been brought up, this enterprise application integration layer or SOA integration layer is basically a middleware or enterprise bus, which helps the different services to be integrated with the customer's CSP's BSS platform. The third layer is the BSS platform, where you see all the BSS service processes are hosted. Okay, the four main BSS pillars which we just shown in our previous slide, these are comprised in this third layer, which is called BSS applications layer. So first layer is the user interactions layer, then it is the integration layer, and then it's a BSS applications layer. So any integration to this BSS applications layer will happen through this SOA integration layer, or maybe API management layer. This is the uniform API management layer, which can help to develop any third-party applications integrating to the BSS platform.
Indrajit, louder, please.
Okay. Is it audible better now?
Absolutely.
Okay, maybe my. Okay, then this is the, just quickly summarize this slide. So this is the first layer, is the omni-channel customer interactions layer, where customer interacts with its CSP for its services. And then we have a enterprise business bus, which is basically an integration layer, so that all the different services which needs to be integrated with the BSS platform can be integrated seamlessly. We don't need to do a point-to-point integration, because point-to-point integrations are costly, and it will be also not agile. If you want to make any changes of any integration, that will become very difficult. That will impact all other integrations. So enterprise bus has been integrated in the BSS stack. Then the third layer is the BSS application layer, which hosts all the BSS applications which we just shown in our previous slide, where we have mentioned order management. See, the order management is showing here, then billing system and charging system, which is a part of revenue management. Okay, then there will be CRM for product management, customer provisioning. We have a partner management also. So these all comprise here in the BSS applications layer. Okay, and then BSS applications layer will interact with the customer network, which comprise maybe a legacy circuit switch network. It could be a packet switch network. It can be other ISP based service network. Okay, and then we have a BI analytics in the third layer, which gives the visibility of this entire process. Okay, BI and artificial intelligence is been incorporated in this layer, which will give a vision to entire BSS OSS stack to customer, and customer can quickly take a decision on its platform. So we quickly go through a couple of the BSS process flow to understand how it works. So one very important data flow is the order management data flow. As I just mentioned, that any new request to for the customer, new request to the CSP services, it comprises of a order. So it order basically a set of actions to be taken to create the service or to modify the service in the CSP platform. Okay. So how it starts? First, you can think of a new customer acquisitions, when a customer to be provisioned into the CSP platform, a new customer acquisition order to be generated. And when a new customer order to be generated, the first it will check whether the customer is completely new or the customer already exists and need maybe another connections or another services. So if the customer is new customer, then first thing what we do, we create an account. Okay, and we create an account in the revenue management system so the customer can be billed or charged. We also create an order to provision into the inventory management system, because when the customer is provisioned with some services, customer is attached to a particular inventory. It could be a mobile number or maybe a IMSI or maybe any other IP address. Okay, so we need it. Order will be generated to fetch inventory management system to see if whether the inventory is free or not. Nowadays with broadband and things, there are also feasibility checkings whether a broadband can be provisioned to the particular address or not. Those things also be checked with the inventory management system. Then actually if the visibility and inventory is secured, then it will be the provisioning of and activation of the services in the network elements. Okay, it could be a HSS, it could be any gateway, internet gateway, it could be any network element which actually provide the services. There the services will be provisioned, and the same time the revenue management systems will be updated with the completion of order, that the in future when the customer will be using the services, the corresponding monetization can be possible using the revenue management system. So this is now order management system creates an account and attach the service with that account. But the ultimately the purpose of the BSS system is to monetize the service. When the customer will be using that service, that customer should be duly charged and the revenue should be generated for the CSP. Now there are two type of mechanism of this revenue realization. One is online charging and another is offline charging. So online charging means as soon as customer is consuming the service, he is charged. Okay, and offline charging is that customer is actually using the service first and he's charged later. Again, this online and offline charging also divided into two parts. One is event driven charge, another is a session based charge. Session based charge means there are if your customer doing some internet browsing, so that means the session is continue when the customer is a multi interaction between the customer and the network. So it's not a single interaction. Customer is continuously browsing some page, or and this is the customer sending request to the network element is sending back the response. So it's a continuity, it's a circular continuity. So this type of event is called a session based event. So session based event can be charged again in a both online and offline mechanism. And there could be a event driven things. Maybe customer sends a short message or maybe an MMS. So that is a single interaction with customer network or CSP. So this generates a single event generated record or single CDR. Okay, each event customer interacts with the CSP, it generates a CDR. Okay, this is a document of what it is using from the CSP platform. Okay, and accordingly though charging can be happen in two ways, as I mentioned. One is online. As soon as customer is using the CSP platform, he will be charged. Actually before he can use the service, his charge he'll be verified whether he has adequate balance or money in his account, and then he will be allowed to use that. And in offline mechanism, he will be allowed to use the service and later he will be charged. Now in the offline mechanism, what we do, there is a network nodes which actually generates the CDF, or it's a 3GPP term. CDF means a customer data a function which is basically responsible to generate a call data record or CDR, which as I mentioned, which is a event record, what customer is interacting with the CSP platform. So that record is been captured in a CDR. Then CDR has been transferred to a mediation, which is called CGF, is a gateway function. And then the CGF that is responsible for to transform that record format into a BSS understandable format, so that BSS can rate it for it to realize the monetary benefit. Okay. This is basically an offline ways of charging, and this CDR can be, as I mentioned, two type of CDRs. It could be an event driven single CDR, or it could be a session driven multiple CDRs. Okay, so based on that, the mediation generates a formatted record which has the information of the entire interaction of the customer interaction of the network, and then BSS charge it and deduct the money if it is a online system, or BSS rate it and bill it if it's an offline system. Similarly, for the online based charging, it's first the CTF, which is called it's a part of network, which when the user or customer initiates a call, and if it is it has to be online charge. There is a profile setting in the HSS. Nowadays it's HSS. In earlier days it was called HLR. It was a profile was set that this customer is to be charged online. So based on that, the customer call redirect to a control node. That control node understand, okay, this customer will initiate some network interactions, so it understand what kind of network interaction it will start, and then it triggers a charging function, because first we need to check whether the customer is allowed to do that network interactions or not. Okay, so this CTF is that network component which triggers the charging initiations, or whether it will try the which will allow the customer to interact with the network based on its balance. So it sent the information to a component called OCS. This OCS is a part of OSS and BSS system, which is responsible to make the charging, rating and charging of the customer event online as soon as customer is doing the interaction with the network. Just another important flow is data mediation flow. Just we have seen that how mediation is important to transform a customer event data record or CDR to a format which BSS understands for the monetizing part. Now this mediation comes with three sub process. One is collection, another is processing, another is distribution. Collection is responsible to collect data from different network elements which actually generate the CDF or the customer call data. Okay, it could be an IMS, it could be a 5G core, it could be a old MSCs. So there are, if customer is making a call from a 2G network, its CDR is generated in a MSC. Maybe similarly for 5G, the CDRs or the call record generated in some different nodes. So mediation will be responsible to collect those call data information using different protocols. Nowadays it's mostly IP based protocol. Earlier days it was even, I see the X25 was used to pull data from the MSC CD. I mean GMSC or the our normal MSCs. They use the X25 in, I mean long back 10-15 years back they used to use the X25 protocol. Now it's all IP based collection mechanism. It happens to capture the call data record into mediation. Then it process. Now this processing, there as you can see there are multiple sources, and these multiple sources may have different format, though there are some standard 3GP specifications for the CDR, but still there are proprietary network elements which generate CDRs in a format which is proprietary. So in processing, in mediation processing, they have a specific logic which understands the source format and use the business logic to create a format which is understandable by the BSS applications. Okay. For instance, you can think of a situation where a company has been provisioned with a VPN connections, and the call between the company employees are free, whether call outside the employees are chargeable. Now, how BSS system will be decided that whether this call has to be charged or not. Now, this in this processing business logic under the mediation, we can create a small database and inform that database with all the CUG or closed user group customer informations, and then let the processing logic write in such a way that if any call happen between these two I mean, same CUG party, then it will discard the CDR or it will make the CDR unchargeable. Okay, so this type of logic is very much possible here. Maybe there could be, I mentioned there could be a situation where a session-based charging, session-based event generated, which multiple CDRs are generated for a call, and but BSS needs to charge it between the start and end. So the mediation can consolidate the different CDR. Mediation can understand the which CDR are correlated, and they have a correlation logic between to identify the different CDRs which are part of the same event generation, and then consolidate that into a single CDR. So this type of business logic is possible in the mediation, and then mediation responsible for the distribution of this CDRs or this newly generated format to respective target system. Now this target system can be a BSS applications which will be responsible for its charging. It could be a data warehouse where it can keep the data for the future reporting on something, or it could be any other maybe any security systems which needs the data, maybe call data record for their processing. So mediation can distribute the process record to different targets for a different purpose. Okay, so our interest will be here for the BSS applications, which will be responsible for the rating and billing of those CDRs. So classic BSS platform looks like this picture. So at the bottom it is a data center which comprise of hardware and storage, and then on the top of that we create database servers or application servers, and on the top of that we install BSN and OSS applications. Okay, so these applications probably maybe we can see there are different BSS applications like it's billing, CRM, order management. So there are different physical servers dedicated for a single applications. There used to be a maybe our order management system may have 3 sub process, then there could be 3 physical servers were dedicated for this order management system. So this was the data, I mean the structure of the BSS platform maybe 20 years back. Now the disadvantage of this if you want to scale up, then you have to buy a new hardware, you have to plug into a data center, you have to configure it. Okay, so entire process takes a very longer time. Buying ordering a hardware and getting it from a 3PP, it takes almost minimum 1 to 2 months to have it in locally, to procure it locally. Then provision it, give it a space in the data center. You may not have a space in data center. So there are a lot of process involved, which is less agile. So this model was not very suitable with the change in the telecom world. So there comes a new concept which Saibal has just mentioned in his presentations, which is called virtualizations. That virtualization means now the physical hardware can be segregated or emulated into multiple small machines. One physical computer can be emulated into multiple small computers with isolation in operating system level. So that means earlier we used to have a single physical hardware, one single operating system instance, and then on the top of that on applications. Now we bring a new concept called hypervisor. That hypervisor actually create an abstraction which is called a hardware abstraction on the top of the physical hardware, and then we can create multiple operating system environment on the same physical box. So if you see this virtualized block, you can see the 6 different computers you can see, and they are basically isolated like a physical machines. Okay, so they cannot talk directly to each other unless we create some network communications or maybe some other thing. They cannot communicate through a process layer. They has to go through a network layer like a TCP stack. They has to talk to each other through a complete TCP IP stack. That means it is as good as a two different physical machines. Okay, only one thing is that they are actually sharing the same compute CPUs and RAM. Okay, so with the advent of this virtualized platform, now we don't have a dedicated physical servers dedicated for the individual BSS process. So we can procure a group of physical hardwares and create a virtualization layer on the top of that, and then create the BSS applications. You can see in these diagrams, we have a physical group of physical systems, like we have storage, compute, network, and we create a virtualization on the top of that. And all the application, BSS application host can be hosted on the top of that. Now we don't have a one-to-one mapping between these BSS application with the physical hardware. Now physical, so the benefit is that now we have better hardware optimizations. Earlier, maybe we have a one catalog manager on one physical server and one charging system, one physical server. And we see catalog manager is not able to use the physical the compute and RAM, but it is underutilized for the hardware. The charging cannot use it because it's electrically separated. Now we have virtualized platform, all are grouped into together. So if my charging system required more CPU RAM, it can ask for more CPU RAM from the virtualized layer. Whether my if my catalog manager doesn't require that, it will be idle, and then charging system can claim that compute and RAM. So this is the advent of over the physical layer, and BSS platform transformed using this virtualization concept. So, but still there are limitations in this virtualized way of doing things, because with the more and more new services are being demanded to a CSP. Now earlier it was only voice and maybe a text. Now it is coming WhatsApp itself taking more and more traffic over CSPs. So CSPs has to adopt these new demands and also transform its platforms accordingly. Correct. So with the virtualization, we see that we progress a lot over the physical infrastructure way of doing things, but still there are the limitations. We achieve speed, but not as speed. We achieve automation, but think of a situation we have a maybe 3 virtual machines spin up, and which is serving a requests for order management. Maybe during some specific event, more workload will be expected. I cannot dynamically just spin up a new virtual machine, because it has to be planned accordingly. You have to secure resources underline physically, then you have to also install the application inside the virtual machine. So maybe we can spin up a virtual machine fast, but not integrating the virtual machine into the application is not easy, because it has to be integrated to different applications also. So that was not easy. It was not that. So that's the agility is not as agility is better than physical world, but not enough. We lowered down the OPEX, because now instead of maybe we used to have one-to-one physical hardware, so our OPEX and because we need more data center space, we used to need more power consumptions. So now with the consolidation of hardware with the virtualizations, we have lower OPEX, but again we have to maintain our own data center. So still it is not enough. So now with the as Soibal shows, with the another concept is called container concepts. As I mentioned, there are virtualization concepts where we break down a single physical machine into a multiple operating system boundaries. So still, if you see even this in this model, we have to maintain different guest operating system. Okay, so that demands more resources, that demand more licenses, and also it is not faster. It's spinning of new operating system and the app, it will take time. Okay, so another new concept evolved during this period. It's called containerizations. The container is basically you have a single operating system environment. On the top of that, you can create a multiple application virtual application environment. So instead of having a dedicated guest operating system for all application instance, now we are having a single guest operating system instance, but they are and we create multiple application environment, but they are still isolated to each other through a process boundary. Okay, so they still cannot directly communicate to each other unless there is a particular mechanism is in place. Okay, so the benefit of this containerization is that we don't need to maintain a multiple operating system, and the spinning of application is very faster. We can develop the application in a container to any laptop or anywhere, and then just deploy that container into a production system or in a customer test environment very quickly. We don't need to create a virtual machine. We don't need to install a OS and then install the operating system. As it is, it's a plug and play. You create a container, inside the container there's the application, you bring the container and just plug into the customer environment. So it is as easy as this. So now with the virtualization and containerization, which are the two foundation of the cloud platform, the BSS now looking towards the cloud platform and try to adapt its own processes and platform from the cloud environment itself. Okay, so the limitations of the virtual environment is now more flexible in the cloud platform. It starts with decomposition. Now earlier we see that the any BSS process, it was a single process. Maybe order management, it's a single process. Order management required two three sub process, but they're tightly coupled. Okay, if one process goes down, the other process will be impacted. If the development also kind of monolith, so if you make any changes to the order management process, it will impact all the three sub processes like this. So it was the services were, though it's within that sub process, the sub process are not I mean decoupled. They are basically coupled at the development. Everything was very tightly coupled. Okay, now with the decomposition or microservice, what Saibal mentioned in his presentations called microservice, that means the entire the process, the business process is break down into multiple small sub processes, independent sub processes, and they interact with each other with a defined interface. Okay, now within even order management process, we have multiple sub processes or microservices, and they're independent to each other. One microservices can be developed in a Golang, where other can be developed in a Java, and they just interact with each other with a well-defined interfaces as per the specifications. So with this decomposition benefits, so the development or making change to any product is more fast. It will be more agile. Okay, then resiliency. So again, as we have more smaller pieces of services within a business process, so it will be demanding that if there is any sub process is unavailable due to some reason, we have to make sure that some resiliency should be there in the platform, which brings up that subspace which is impacted, so that entire process remains unaffected. State optimization. So earlier it was single business process tightly coupled with the database. Now with the decomposition, advent of the decompositions, the microservices can have its own database, and it can have its own data and its own business logic within the microservices. Orchestrations will be very important, because the deployment of application, the changes of application should be automated to reduce the OPEX, and also to make it more faster and more agile. Okay, so if you want to bring any product, it has to be during the morning. You have to maybe probably customer CSP will create a product, and it has to be tested and deployed in the production by the evening. So this kind of faster changes is expected in nowadays BSS platform. So orchestration is very important for any cloud BSS platform. Then openness, the BSS platform should be not be tightly coupled with any particular platform. Customer can choose to host his BSS platform to any platform. Okay, it could be AWS, it can be Oracle, it can be any cloud platform. And then it's very important that as I mentioned, the choice of platform. Customer can easily plug and play its BSS platform from one cloud vendor to another cloud vendor. These are the basic drivers, or basically these are the primary points which drives the BSS to move towards the cloud platform, as a cloud platform is evolving itself, and same time BSS products are also evolving to fit into a cloud platform. So this is the whole picture now transformed from the virtualized BSS to the cloud BSS. If you see that earlier it was hardware and then virtualization layer, on the top of different virtual machine hosting the applications, BSS applications. Now it completely changed. Now the data center is no longer with the customer. It is with our hyperscalers like Google, AWS. They have their data center in multiple region. Within a region, they have different availability zones, which provides the resiliency of their hardware, software, and network. And then we have hardware, storages, hardware, and software from the particular geographic region, which is the hyperscalers are responsible. Then virtualization network layer, as I mentioned, that cloud also leverage very much the virtualization. Okay, and then there are auto scaling and geo redundancy. Auto scaling means if there is any demand for any compute resources or any virtual compute, it can be done immediately based on demand, or it can be auto scaled based on the utilization. Suppose we have procured 3 compute machines and agreed with the hyperscaler that if your resource utilization increase by 80% or over and is sustained over 5 hours, then another machines will be spin up automatically. So this kind of benefit is there if you go with the cloud platform, the public cloud platform. And then, as mentioned, that Kubernetes is the new player here. Earlier, we so far till these presentations we are talking about the virtualized platform, but we just quickly touch upon the containers. Now, the containers are not basically, as I mentioned, that containers is basically small application environment hosted on a same operating system environment. But containers, only container runtimes is not enough to host application using within a containers. Okay, so Kubernetes is the orchestrator which helps to orchestrate the container life cycle. As I mentioned, that if order management system maybe have 10 microservices within that, that means we have maybe 20 containers running to serve that microservices. Okay, all these 10 microservices. Now, suppose one of the such microservices goes down due to some reason. So who will bring it up? Who will monitor it? So there comes our orchestrations, or one such orchestration is called Kubernetes. Now, Kubernetes is the orchestrator which plays such a role here. When you deploy a container, Kubernetes decide where to actually schedule that container in which compute flat node. If a container is down, Kubernetes looks into that and see how its states can be maintained back. It is also depending on the auto scaling. If you mention that we need 3 containers, and probably that could be, if there is a high usage, it can be scaled up to 5 containers. Kubernetes is the orchestrator who will do that. Okay. Now with this cloud enabled platform, Kubernetes is part of the cloud providers or the hyperscalers. Okay, we'll see how AWS or Google, they provide these services as a container platform, container orchestrator to host the containerized BSS applications on the top of cloud. So this is a kind of a blueprint how a cloud typical looks like in AWS platform. So this is a reference architecture you can think of. So so far, whatever the applications we were discussing earlier, it was a physical machine based applications like order management, CRM, all are basically physical hardware initially. Then it transformed to a small virtual machines. Nowadays, with the advent of cloud and Kubernetes, now basis applications are broken down into small microservices, and these microservices are comprised or hosted in different containers. Okay, so if you see the cloud platform reference architecture, if you can see that basic cloud platform is subdivided into multiple resiliency zone. It's called availability zones. That means if some resources are part of one availability zones, you are consuming it, and if you are that availability zone is not fail due to some reason, if there is a hardware or software failure in that reason, the services can be gained from the other availability zone. Okay, so this way the resiliency, that multi-data center resiliency, is inbuilt inside the cloud. Otherwise, in a physical world, we have to create multiple data center by our own. We have to create the data center, we procure space, power, hardware equipment, connectivity to create all this kind of resiliency. Nowadays, it's all inbuilt with the cloud platform. So we can create a BSS platform like on this top of this cloud platform, and this cloud platform hosts, if you see a Kubernetes, if you can see this diagram, there's a Kubernetes offering with the cloud platforms, and this Kubernetes platform is across the multiple availability zone. That means if my Kubernetes nodes are down here, I can get the service of Kubernetes from this another availability zone. Okay, and the BSS platform nowadays in the cloud environment are hosted on these Kubernetes nodes as a containers. So if you are consist of a order management, maybe it has a 10 microservices, and maybe it will consist of a 20 containers, all these containers will be distributed across these availability zones. Maybe one container for one service here, another container for here, so that if this goes down, I can get it from here, like this. It can also spin up multi-containers here. Suppose I need at least 3 containers at any cost. So, and my availability zone is down. So my availability zone 2 can spin up 3 containers here itself. So this way BSS is more agile, more resilient, okay, and highly scalable in the cloud platform. And for the accessing of BSS services, we use to the cloud platform. The cloud platform has a feature called Route 53, which is basically a DNS. Maybe you want to access your order management URL. So you have a DNS configured in the AWS Route 53, which can publish it. That user can use that URL to connect to the order management, and then it will be through a load balancer will be used to distribute the order management traffic to multiple container. Any request user put, then that come to a load through a load balancer, elastic load balancer, and that can be distributed against a multiple microservice containers based on this business logic. Okay, and if there is any failure in one availability zone, the traffic will be shifted to another availability zones. Databases also, you can see, as it comes as a service, you don't need to build our own database. It can be demanded to the hyperscaler as a on-demand database service, and applications can connect to the database service here. And also, this is also like other Kubernetes services, the database services are also resilient. It can be created in multiple availability zone for high availability. Okay. So this is in summary the different cloud services which are required for to build up any BSS platform in the cloud. This is keeping in mind the AWS platform. There are though other variant, but the terminologies are different. Maybe we call a VPC, somewhere it is called different virtual network like this. In Azure it will call virtual network. So there are, like here it is called EKS, there it is Azure Kubernetes like AKS. So these are the terminologies are different, but the components remain same across the different hyperscaler providers like Azure, Google, AWS, IBM Cloud, DigitalOcean, like this. And one last slide from my side, that the benefit of this BSS platform or cloud is on demand. You have to you can pay as an when you use it, okay, and you don't need to maintain your own database data center into this. The resiliency and agility is inbuilt in the cloud platform, but at the same time it comes with certain downsides, like probably once you migrated your data will be in with cloud, but there are nowadays hybrid cloud models are evolving where data probably resides with customer premises, and there are benefits. Cloud benefits are also leveraged at the same time. Security is major concern today with the cloud. There are developments ongoing to make it more secure and more agile to the towards the CSPs, and there are more changes happening in this world. So it's a continuous process. It is a though it is a new things, and that, but still it is going to stay, because now we see there are big players like Horizon, where Verizon, they are moving there some of the application to the clouds. So in future we'll see more and more such migrations will happen from on premises to cloud on this BSS platform. So with this, I end up my presentation here. Thank you very much for your time. I didn't get a chance to take any questions during these presentations. Maybe if there is any, I can quickly take a couple of the questions.
Thank you.
Thank you, Mr. Nandi. We will have a question answer session now. And I think your audience some questions are there. And Mr. Ghosh was trying to answer some of them. So I saw he's typing the answer. I don't know whether he's completed the answer. So should I read some of the questions to our experts? You can see, Mr. Ghosh, the questions?
Yeah, I can see the questions, so I didn't answer them.
Please, both of you can share the answers, right? Yeah.
Okay, so let me see the questions. So the one question is, what are your views about multi-cloud migration? Also, your views on Kubernetes as an orchestrator. So so I assume that the question is being asked about multi-clouds being used simultaneously. Well, this is something which is in vogue these days, because you don't want to be locked into a single vendor. One of the reasons we use multi-clouds, and also there are features in different clouds which are different. So multi-cloud is pretty common these days. Kubernetes as an orchestrator, I mean, it's the orchestrator that is used, as Indrajit pointed out, is being used everywhere. Alternatives would be Docker Swarm, but I don't think Docker Swarm stands chance with Kubernetes, because Kubernetes has many more features and many more mechanisms through which it can actually make orchestrate the whole structure. I mean, there's lots of more in Kubernetes. I'm only mentioning a couple of things that, like, the security feature in Kubernetes is much more advanced than in Docker Swarm. So this is reason enough for Kubernetes to be there as an orchestrator. The other question is, do we have any indigenous cloud infrastructures? So not quite sure what this means. Not very clear what is the exact meaning. So I will skip this question. If the original
I
poster
believe
can.
that Amazon or Microsoft or Google or international companies, I think no, we don't have any Indian company as far as I know, as a cloud service provider.
Yeah,
No,
I'll
no,
answer this. I'll answer this question.
Yeah, please.
Geo is making a cloud platform, and it will be coming as a public. It is under the test trial. So still in this, at this time also, it is in a public cloud mode. It will be basically today it will be utilized for the 5G platform, but some of the portions it will be also released as a public cloud. So the test and other things are going on. The government and other paraphernalities like the commercials and the government node and all other things are pending. So based on that, it will be getting released. Okay. So then, and some more cloud platform on the indigenous platforms are also in the foray. Okay, Mr. Ghosh?
Yeah. Okay. So
We'll wait for that to have our own cloud. And one question I could see here with Mr. Purushottaman Nair has asked this question, whether an universal rate tariff fixed for availing resources in cloud. So the experts can, any of you, Mr. Nandi or Mr. Ghosh. So,
no, actually, I answered that question initially.
okay. Okay.
So
I have not
that's
seen
all.
the answer. Yeah, that's it.
Yeah, I just
You can share
He
with
has
the
already answered
audience.
the question. It is like the pay per use. Already it is the standard norm.
Okay, that's good. So I think we have our experts answered all the questions. I don't find any other questions on that. So now our experts has put us in cloud 9. So we'll take some time to get down from that. So that way, I'll request Professor Brahmo to propose vote of thanks. Just 1 second. Sudeep, do you have any of the VIP guests on our list? Sudeep? I cannot see anybody. Chanchal, you can see anyone? I think other than 6 of us in the panel, nobody is there.
No.
Okay. Professor Brahmo,
Yeah.
may I request you now to kindly propose the vote of thanks?
Okay. Thank you very much. Actually, my subject is a little bit different from this cloud computing, but I understand that the cloud computing is also using in our genetic engineering concept to mobilize and to understand the complex genetic mechanism through cloud computing, how it is been actuated or it has been used. That is not very clear for me. But I understand that whatever any cloud computing or any modifications of that type of computation processes, some practical data has to be be modified so that the data acquisition
Sir, we are unable to hear you.
The screen got locked.
Oh. We have his contact number. Check. Shudeep, are you online?
Yes, sir.
Just Professor Brahmo, just check with him. Do you have his contact number?
Yes, sir. Professor Brahma, I also cannot.
I think he
I
got
think some
disconnected.
network problems, sir.
Might be right.
Some network problems.
So just wait for a minute to see if Professor Brahmo can come back.
Yes, sir. Yes, sir. Yes, sir. Then otherwise somebody you can.
Yeah, then otherwise I'll propose the vote of thanks.
Yes,
No
yes.
problem. Shudeep, I could see Mr. Kamal for a fraction of a minute, I believe. And do you have any other Mr. Bhomik is available by any chance?
No, I think the 5 panelists are there.
Yeah, but
Beyond that,
because
nobody is there.
just a second, Professor Brahmo's number should be here. I'm trying. No, his number is not there. His email ID is there. Okay, I don't have his mobile number.
Ramda, else you continue and you can give
I
the
think.
vote.
Okay.
You can give the vote of thanks, sir.
Yeah. I thank all the participants who has, I think at some point of time, it was more than 60 participants were there from all over the country. And thank you very much for Professor Brahmo is coming again. So very good. Again. So, and then I extend my sincere thanks to the panelist, Professor Brahmo. We are unable to hear you, sir. I think just wait for a minute for him. This is trying to come back. Because it is customary for the honorary secretary to propose the vote of thanks.
Am I audible?
Yes, sir. Please.
Oh,
Waiting for
I'm
you.
sorry. The cloud computing was irritated regarding my
No
criticism.
problem.
I started to make it compatible for the human system.
Uh-huh.
I'm very much compatible to human system, than the computing system. So on that starting, I'd like to give my vote of thanks in the process of systematic process, like our cloud computing. It is my proud privilege to extend my sincere thanks and gratitude to all the distinguished participants in the technical webinar on the theme cloud computing. I in my home, line is dead. Organized by the Electronics and Telecommunication Engineering Division of West Bengal Trade Center, IEI, through online platform Zoom. At the outset, I convey my sincere thanks to the panelists, Mr. Shaival Ghosh, security lead of principal solution architect, Extension Limited, correct, Mr. Indra.
The network issue, I believe.
Delivered their lecture. Am I audible?
Yes, sir. Please continue.
Okay. Just let me complete it quickly. So, I thank also, my sincere thanks goes to my colleague, Mr. Sandeep Kumar Dev, Chairman, West Bengal State Center. He was not present today, although I have to send my greetings to him. Our beloved President IEI, Honorable Sri Narendra Singh, Professor Dr. Tara Singh Kamal, Chairman, Electronics and Telecommunication Engineering Division, Board of IEI, Professor Dr. Shapan Bhumi, Chairman.
Sometimes network creates such a problem.
Make this today's technical webinar a success. Thank you all for a kind participation as well as a silent hearing of that important aspect. Thank you, Ramchandra.
Thank you very much, sir. Okay, thank you. The
Thank you very
panelists,
much.
and thank you, Chanchol, and thank you all the participants. Thank you, Sudeep, for your kind help and support. Look forward to our November webinar on 26th of November. Let's see.
Thank you. We will make it.
Okay, thank you very
Thank you
much.
so much. Thank you so
Thank you,
much.
sir.
Thank you.
Thanks,
Hello.
Mr. Shaival and Mr. Indrajit for giving the beautiful lecture today.
Very good, very lucid, very
Yeah.
informative, and really
Excellent.
with very good depth of the subject. Excellent.
Thank you so
sir.
much. Thank you.
Okay,
Right.
sir. So, sir, with permission of the chair, can I end the webinar?
Yeah, please.
Yeah,
Okay,
please.
thank you. Thank you,
Sudeep,
sir.
only
Thank
you can do that.